Force and pressure. Force and pressure. This is our lecture in this slide. We have some words that are concepts. Word. Here, what is the meaning of a force? What is the meaning of a force? Before we move on this word, first of all, let's understand what is the meaning of the lecture. What is the meaning of the lecture? Force word and pressure. Force. It is saying we will apply force. Then what will happen? We apply force like that. Okay. We take something. For example, I am taking up this book. So here I applied force. I applied force. So force is just a pull or push. That's it. Force is just a pushing or pulling on something. Okay. Something can be object. Something can be object. So it is just you can remember it. Just remember what push or pull. When we push something, here we are applying force. Now pull. One more sentence you can understand what when you will apply, when there was applied force, so position of object has changed. Position of an object has changed because of applied force. Okay, that's one. For example, for instance, this is a marker, and here I will take this marker like that. So here I applied what? I applied force. That's why position of this marker is somewhere instead of here. Now position of this marker is here because of I applied force. That's why. So whenever force will be applied, so position of an object will be changed. Okay. Yeah, it is a universal truth event. So it will happen. We are 100% sure that it will happen. What position of an object will be changed when force will be applied. Force can be pushing, force can be pulling. Something. So clear about the force. When force will be applied, then position of an object will be changed automatically. Yeah, here we can see what with respect of time. Here you can also observe that here will be what motion, but our focus will not be on motion chapter. Okay, here chapter lecture is what force. Lecture is force. Yes, there is what something is an object. This marker is in rest, and I am going to apply force to this marker. So of course this will come into motion. This marker will come into motion, of course, after applying force. But before applying force to this marker, this was in rest. But as I applied force, it came into motion. Yes, it is happening. One thing, this is one thing. Second thing, what position of this marker, position of an object will be changed when force will be applied. Yes, sir, we will understand, but let's explore about force. Then after completing this force concept, we will move on pressure. Yes, there is a connection of pressure with the force. Now here, contact forces. contact forces. Contact. So something is in contact. For example, here this is contact of this marker is with my hand. Contact of this marker is with my hand. Okay. Cap contact of this marker is this with this object. So something a contact connection of something is with something. Contact force. For example, friction. In the context of force, what is a contact? What is a contact force? So it is the same. Two bodies will be together, and two bodies will be applied either force or force. Two bodies. For when it comes to friction, so friction will happen. How will friction happen? How will friction happen? This is friction. So of course, as you can see, this is an object. I will move this like this. So here, this object is going in this direction, but this hand is going in this direction. So this is surface touching. Surface of this object is touching with the surface of this hand, and both direction of both will be opposite. Direction of both objects will be opposite. Direction of this object will be in this direction, and direction of this object will be in this direction. It can happen that direction of one object will not be changing. Friction will happen. It will be possible when two bodies are together and both are moving up in opposite direction. Both are moving in opposite direction by touching both surfaces. Muscular. It is saying what? This is a muscle. This is made of muscle. Inside this is what is found what bones. But this is muscle. I am rubbing my hands, both hands. So here, this is what friction. Because of here, surfaces of both hands are moving in opposite direction together. So when I move this hand like that, so here friction happened. Okay, here friction happened. Our focus will be on surface of both sides. Both surfaces of both objects. There is a ball, and ball comes like that and goes like that. So here ball is acting as a friction. It is behaving as a friction. Surface of a ball will rub with the garden. But here garden is still in a rest, but ball is in motion. Yes, I told you it will happen. One object can be in a rest, but second object would have to be in motion. Then there will be fraction. If both objects, for example, both my hands are in rest, so of course both hands are in motion, but both hands are not doing any kind of friction. No. There will be friction when one object will move. one object will move by rubbing the surface of the other object. For example, this hand, will rub the surface of this hand like that, and this hand will move in any direction. It can move in this direction, it can move in this direction. Okay, it doesn't, we don't care, but it should be moved. One object should be moved in any direction, but by rubbing the surface of the surface of first object with the other surface, of other object. Okay, so that is how friction comes into picture. So muscular also we saw. This is hand is made of. I want to ask you, how was it made? By plastic. This is made of a plastic, isn't it? This is made of a plastic. Now you cannot say that this is made of a muscular. Can you say that our hand is made of plastic? No. Our hand is our hand made of iron? No. Yes, you can say our hand, our body is made of muscular. Is made of muscular. So here, my both hands are an example of muscular. One hand move like that, one hand move like that. So this is a fraction. This is a muscular fraction. Muscular forces. For example, I want to pick up this. Marker. So I will apply what? Muscular force. Okay. To pick up this marker, I can apply what? Muscular force. My hand is a muscular. But here friction force, it can be by two objects that are not muscular, that are not made of muscles. Now these two markers are doing friction, are doing what? Friction. Are doing friction. So here we are applying what? We are applying force to this marker like that. That's why this object is working as a friction, as a friction. Now let's move on this non-contact force. From word you are crystal clear. From word you can be crystal clear. If you are then here there will be contact. There will be contact of one object with another object. Then there will be what? Frictional. There will be muscular force. But when it comes to non-contact forces, so we can say there will not be any medium. But there is a still force. But point is what? Our focus is on there is no any medium. Okay, one object will act as a force, but there will not be any contact with that force. So one object will be still alone, but their contact of that object will not be with any object. Okay, will not be with any other object. But that object will be acting as a force. So those objects we will consider as non-contact forces. First example, which is a very famous example. gravitational. It is said an apple fall from branch of a tree. So how it happened? How it happened? Most of a person, most of a person replies that it happened. Apple fall down. Apple fall down because of the reason is that it is uh, it is said by most of the people that apple fall because of a gravitation. Reason is just a gravitational one. Okay, gravitational one. But how can you say? I am not clear. I have still doubt. How is it possible? Why it is falling down, not going upward, not going upward? Why? We will explore a lot of things about the gravitational gravitational in separate lecture. Here we needed to understand a little information, you can say. For example, here we are understanding force. So gravitational is a kind of non-contact force. Okay. Uh, they don't need any other medium. They behave as a force. They behave as a force. They alone can act as a force. Okay. Magnetic. Magnetic. Yes, magnet. There is a magnet, and here is a one magnetic material. Just put both, but position of both uh, should not be together. Just separate like that. Okay. Now there is a magnet. There is a magnetic material. There is a magnetic material. Now magnetic material will come will attach. Magnet will attach this magnetic material like that. So here we will not apply any external force. We will not apply any kind of external force, but this magnet will attach this magnetic material. As you know, magnet attracts magnetic material, not non-magnetic material. For example, this is a non-magnetic material. Okay, iron is a magnetic material. So we will keep here what magnetic material. Then this magnet will attract this material. Now here we will not be applying any kind of external force. Any that's why we are saying magnet is a non-contact force. That's why we are saying. Now here. So from this discussion, you understood there can be two types of, yes, there can be two types of force. One contact force, second non-contact force. Contact force, which there will be two forces. One force needs what other medium, needs other object, you can say, to be friction, not fraction, to be friction. So contact force, a object will have other object to be force, Now non-contact, one object will be what, one object will not be dependent. You can say clearly one object. In the case of non-contact forces, one object will not be depend on another object forced to be forced. But contact force will depend on another object to be forced. Now here, net force. It is the same. Net force, which means total force. Okay. Total force. So here, I think so. SI unit of a force is said what Newton, as a Newton. So SI unit of a force is what? is Newton. Is a Newton. Okay. SI unit of force is a Newton. We will represent force in mathematics as a Newton. Okay. We represent it in mathematics by n alphabet. By n Newton. Now I am applying like that. I am applying like that. This in this direction and this in this direction. Like this is going this direction, this is going this direction, and I am applying. I am applying force. This hand is pushing. This hand is pushing this hand. Let's say this is A and this is a B hand. Okay. A hand is pushing B hand and B hand is pushing A hand. So now we have two force. Okay, 1 second. Both are pushing to each other. So here net force of this and this would be 0. Would be nothing. There is no, because both are pushing to each other. If one is still in a rest, and it is not applying any kind of a force, but A hand is applying what force. So of course position of this will be changed by applying force by this hand, like, because this is in rest, this is in rest, but both are in motion, both are pushing to each other. We would say for net force is 0. Net force is 0. Now force of this A hand is what? 2 Newton, and it is pushing this hand by 2 Newton. So of course net force would be 2 Newton. So let's say 2 plus 1. Okay. 2 plus 1. One example more for this. I applied here 1 Newton force, and again after few seconds I will have applied how much? 2 Newton. So total Newton how much? We say what? Total net force. Net force is how much? 3 Newton. Like that. So here from net force concept you will have numericals. Now this is opposite direction. Forces of two objects are pushing to each other in opposite direction will be net force will be 0. So of course balanced force. It is saying one force this side, one force is coming this side. One object this side, one object this side, and this hand is also applying force, and this hand is also applying force. So Newton of this is how much? 2, let's say, and Newton of this how much? Newton of this is how much? 2. So both are equal to each other. That's why we would say there is a net force 0. Otherwise you can say 0. Okay. 0 we are saying because of both are pushing to each other in opposite direction, not in straight direction. That's why we cannot say that there would be 4 Newton. No. Here, if one object is pushing to another object with 4 Newtons, but second object is not applying any kind of object, and one object is applying how much force? how much newtons? 4 newton. So 4 newton is what? 4 newton is what? Total total net force. Okay. So balanced force will be equal when both Newton of when Newton of both objects will be opposite, will be equal in opposite direction, will be what? 0. Net force will be 0. Net force will be 0. Now here net force is not equal to 0. When it will happen? When will it happen? So it would happen when yeah, if this hand is applying how much Newton? 2 Newton, and this hand is applying how much Newton? 1 Newton. So now tell me, what will be now are both applying balance force? Balance force? Not. This is 2 Newton, this is 1 Newton. So it is applying 1 more Newton. So this is strong, this is strong, this will be strong. So in the last, at the end, this hand will win. This hand will win. Okay. So here 3 and yeah, not force. Net force would be 1. 3 Newton from this object and 2 Newton from this object. So here 1 is more, 1 is more. So 1 is more is being applied by this object, will be this object will be more powerful, because of this object is applying 2 Newton and this object is applying 1 Newton. That's why. So that's how you will find the net force of any object. Effects of a force. Effects. What are effects of force? When a force will be applied with an object, then what will happen? Then what can happen? When force will be applied with any kind of object, then what will happen? Let's say this is a cricketer person throws what? A cricketer person throws ball like that, throws ball like that. So here that person applied what? Force to ball. So force motion of a speed of a ball will be what? Will be increased. Will be increased by applying force by that person. So here that person thrown what? Ball with a speed of let's say, I don't know. That person threw a ball like that. So here ball came into motion, and here motion of this ball is what? Is increased. Initially this ball was in rest. Now that person pick up this ball and then throw like that. Now this ball came into motion, and now motion of this ball is increased because of this was in rest. That's why this was in rest, and suddenly that person pick up the ball and throw like that, and motion of this object came decreased. Okay. Now here increased, not decreased. decrease in speed. Ball is coming. Ball is coming. This person thrown ball and ball will go to the another person. To the another person. Now ball will receive to the another person. Gradually, slowly, a speed of a speed of ball will decrease. Will will be decreased. Will be decreased. Will be decreasing by friction. By friction. Yes, by friction. So slowly, a speed of that ball will be decreasing because of a friction force. And friction, there is a friction of that ball with the ground. So that's how ball a speed of ball will be what will be increased, will be decreased, will be decreased, will be decreased. Okay. Change in direction. Change in direction. Change in direction. Here, this is hand. Okay, this is hand. Now I am applying force like that, like that. So here, a speed of this hand came into fast. Came into. Now speed of this hand is fast. Here I applied force. Now a speed of this motion is what decreased because of I applied force, and this was in rest. This was in rest, and I suddenly applied force, and it came into motion, and now motion will be what high. Motion of this will be fast. So we can say motion of this hand is decreased, is increased, not decreased. Now decrease in speed when this hand is in motion. When this hand is in motion, now slowly I will not apply. I stopped to apply what I stopped to apply force. So this hand gradually will stop. So like that. Okay. When there is a not being applied, when force is not being applied, so motion of that object will decrease. Slowly. Change in direction. Change in direction. This is one point. Let's take an example of this marker. I can pick up this marker. Now here I applied a force. I can take this object this direction, like that. This direction, any direction. In any direction I can bring this like that. Okay. So here we are changing direction of this marker. We are changing like that. We can change the direction of any object. Let's say how can I give it? Marker was here. Now let's say this is in a horizontal. I can change the direction of this marker by applying force. But how? By applying force. Like I will pick up this marker. So here I started applying force. Now anywhere I can put this marker. So here, in other words, we can say we are changing direction of this marker. Okay. Now next. So from this you are crystal clear. You can change the direction of any object by applying force. This is effect of a force. This is effect of a force. You can decrease a speed of an object by applying force. This is effect of a force. You can also increase the speed of any object. It is also effect of a force. You can change any you can change any kind of object in any direction. It is also effect of force. Now change in shape. It is another interesting point, but you will understand it very. Let's say you are cutting a vegetable, okay, and taking like that example, so that you can relate. You are cutting vegetable. Uh, you have taken potato. Now you are what? You are cutting potato. So here you can see, you can observe, before cutting the potato was shape how, was looking how, you can say shape, a spherical shape. Potato, look of the potato was in a spherical shape. But after cutting that potato, it came into what you can say, like, initially shape of this potato was like that. But after cutting like that, okay. So after cutting this potato, the shape of this became this kind of a shape. Suppose there is a change. There is a change. There is a change of a shape of this potato, which is like that. Suppose here we applied what? We were cutting the potatoes. Here we were applying force by our hand. We were applying the force by our hand. That's why we were able to cut this potato, and it is shaped in this, like that. It is shaped like that when we cut this potato. So of course we can change shape of any object by applying force. It will happen when we will apply force. Okay, it is also a effect of force. Okay. Even let's say second example. Okay, this is like that. I can roll this like that. This is a page. So let's say this is in a square. Shape of this page is a square. Shape of this page is a square. I can make this page. I can shape this page as a cylindrical. Now shape of this page is what? Cylindrical. But initially shape of this page was you can say a square or rectangle. But after applying, I am applying force. Shape of this now it became a spherical. So that's how you can apply force to change shape of any object. That's all. Okay. Now we will represent a force as a Newton. Okay. We can represent Newton word as in a letter. So Newton is a SI unit of force. I think now we should take some questions based on this concept so that we can have more clarity. Next question. This is we have question. This is we have question. It is very simple. It is very easy. A force acting on a ball. There is a ball, and a force is being acted on a ball. So it cannot do what? It cannot stop the ball. Can it not stop the ball? I think uh, when force will be applied, when when ball will be acting as a force, so ball can be stopped by applying force. Ball can be stopped by applying force. Okay, by applying frictional force you can say. So this would not be answer for this question. Second is what a speed. A ball cannot speed up the ball. Speed up the ball by applying force. By applying force to a ball. By applying force, ball can be a speed up. Ball can be a speed up. We can decrease the speed of a ball by applying force. So of course this is not a answer for this question. Again, change the ball's mass. Change the ball's mass. Yes, by applying force, I cannot. By applying force, I cannot change this the mass of the mass of this object. Nobody can change. Not only me. Nobody can change mass of any object by applying force. By applying force, I cannot change mass of this object by applying force. So this is answer for this question, and question was asking By applying force, by applying force, a force acting on a ball, it cannot stop, it cannot uh, it cannot change, it cannot change the ball mass. Yes. So D is saying slow down the ball, slow down the ball. Yeah, ball can come in slow motion. Ball can come in slow motion when there will be frictional, then when there will be frictional force, then it can come, ball can come in slow motion. Okay, it can happen, it can happen. So a speed of a ball can be decreased by applying frictional force, by applying force. A speed of a ball can be increased by applying force. Yes, it is also true. uh, Ball can be stopped by applying muscular force, by applying any kind of a force. Ball can be stopped, ball can be increased, ball can be decreased, but ball cannot no, 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 no. Force, ball cannot be changed, ball cannot change, no, no, force cannot change the mass of the ball, force cannot change the mass of the ball. This was answer for this question. Now next question, which is very interesting. We have this next question. It is saying a fielder person is catching coming ball, is catching coming ball. So a fielder is catching a ball as shown in figure. If the ball is in the air, if a ball is in the air and fielder is like this, fielder is like this, and ball is in the air, identify the forces acting on the ball, acting on the ball. But ball is not in the hand of fielder person. Fielder person. Ball is in air. Ball is in air, and we have to tell which kind of a force is acting on the ball. So of course here gravitational and muscular force. Muscular force. Gravitational we can say gravitational force is acting on the ball, but not muscular. Muscular, which means Ball, ball is in our hand. Ball is in our hand. It is a muscular force. So this would not be answer for this question. Next, gravitational force only. Yes, 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 it is true. But what else? Apart from this, what else? We have two more options. It is true. Air friction force. Yeah, yeah, yeah. It is also true. How? Question is saying ball is in air, and air has particles. Air has particles. If teeny particles even we cannot see, we will have to use what? Telescopes. It is said. Telescope is a device from which we can see a teeny objects that our eyes are not able to see. So that device we will have to use to see teeny particles which are present in air. So air has particles, a lot of particles. So of course particles will touch. You can say particles, air particles will touch the force, will touch the surface of the ball. So yes, particle is another object, you can say, and ball is other object. There are two objects. So both will do what? A friction. And which kind of a friction? Air friction. Because of there is a air. There is a air. Okay. So this kind of friction we name it as a, we call it as a air friction. Okay. Air is a ball is in air, so that's why there is a air friction is acting. Air friction is acting on the ball, and gravitational force is also acting on the ball. Ball is acting as a gravitational force. There is a no another medium. There is a no another medium. So I think I would say D, gravitational force and air friction. Gravitational force and air friction. Okay. Now next question. This is next question. What is it saying? We have to identify which one case is behaving as a unbalanced forces. Identify the cases where unbalanced forces are acting. Unbalanced. It means net force will be more than zero. Net force of object will be more than zero, and unbalanced force will not be equal to zero. Okay. A rope equally, a rope, this is rope, this is rope. A rope equally pulled at both sides. So we have a rope. Okay, we have a rope, and there are 3 person, and this side also there are 3 person. This is 6 person is pulling this 6 person is pulling a rope equally with equal Newton. Let's just say this side is 15 Newton, this side is also 15 Newton. This 3 persons are pulling this one rope with 15 Newtons, and this 3 person which is in other side are pushing this same rope with 15 Newtons. So it means this process is telling us that both. So a rope is being pushed by 15 newtons in both sides. So it is equally, it is a balanced force. It is a balanced force. Now a car at rest. So if the car is at rest, there is nothing. Car is at rest, so you can say net force is zero. A woman leaning on a wall like that. Woman is like that with a wall. Wall is in rest, but woman is also in a rest like that. Woman is also in a rest with a ball. So net force is zero. Pushing a ball in the hole. Here there is a ball, and a person, there is a ball, and that there is a hole to this ball. One person is standing here. It is applying force to the ball like that, and ball will go to the hole and will go inside the hole. So here person applied how much? Let's say person applied 16 Newton. 16 Newton. Yes, 16 Newton force. So this person applied 16 Newton force. Then this ball came into hole of goal. So here this person applied only this person applied how much? 16 Newton. And ball was in a rest. So you can see what is happening. In this case, 13 and equal to 13. 13 equal to 13. Now in this case 0 0. In this case also 0 0. But this is for this, this is for this, this is for this. Now this is for this. So person applied 16 newtons to the ball, that so that the ball can go into hole. 16 and 16 force of ball was how much? Nothing. Ball was in rest. We can say force of ball was 0. force of pole was 0. So how much? 16. So it is not equal to 0. It is not equal to 0. So we can say this is unbalanced. This is unbalanced force. This is an example of an unbalanced force. So here, pushing a golf ball is acting as an unbalanced force. Here, other object was what? Ball is not applying what? Any type of force. If not applying any type of force, we can say ball has 0 Newton. Ball has 0 Newton. But person was applying how much Newton? 60 Newton. We can say person had 60 Newton, and those 16 Newtons applied who? Person. So D is the answer for this question. D is the answer for this question. Now next question. This is next question. You have to tell answer very carefully with logic. Two objects repel each other. There are two objects, one this, and these two objects are not attracting to each other. Rather, they are repelling to each other. Like that. So it means they are pulling. Yes, both objects are pulling to each other like that. Okay. Now this repulsion could be due to we have to tell which kind of force will be there. Which kind of a force? A is a frictional force only. Frictional force. Okay. Frictional. Electrostatic force not. It is so here first point, are you clear? It is a contact force or non-contact force. So I think it can be. It could be magnetic. So I think answer would be D. Answer would be D. Because of repulsion. What is the repulsion? Repulsion is coming. Attraction, repulsion. R for magnet, R for electrostatic, R for I think so. But this is not saying. This is not saying what attraction. So magnet can repel, magnet can attract, but electrostatic cannot repel. It attracts. But answer, I think this D would be answer. Frictional force, not these two objects are not. So yes, frictional force can be there also. So of course this is answer. How is this answer? We have to explain. Reason we have to explain. Why is this answer? Look. What is the repulsion? What is the attraction? Then you have to be clear, alert. What magnet behaves? Magnet repulse two bodies when N and N they are both similar. This is one magnet, this is second power magnet. Now here see carefully, ends of both these magnets is what? N. Okay, N. So both are similar, that's why they will repel to each other. So from here, are you clear that yes, magnet will repel to each other. So this was what? Magnetic. Now what about electrostatic? Look, let's say this is minus. I don't know electron. Okay, these are electrons. These are also electrons. This is a hint of minus. This is a hint of electron. Minus. So if electrons, it is also said electron plus proton. Okay, electron, proton. There are two charges in the case of electrostatic force. There are two charges, electron, and there are two things, electron and proton. So if there are two bodies have what? Two bodies have one thing similar, electron. Okay, you can see this body has what? Electron, and this body has what? Electron. So both are similar, that's why both will repel to each other, not will attract to each other. Okay, not will attract to each other, because of both are electron, both are similar. These two bodies will attract to each other when one thing will have what? Proton. One thing of them will have what? A proton. Then two bodies, they will attract to each other. But you can see from this diagram, they have what? Both similar electron. That's why they have both similar charges. That's why they both will repel to each other. So these are reason we were saying that the day is correct because of this is reason.